Hello everybody, I'm back with another hour session. So today I thought I'll discuss whatever I did to backtest the mean variance portfolio strategy and give out the codes for it so that you people can test it out and modify it or try it out by yourselves. Okay, so let me just share my screen. Okay. So today was quite a bit of disappointment actually, because I worked quite hard at this project, you can say. So basically I spent approximately cumulative of 6 hours or 7 hours of hard coding, like basically focused coding, and eventually nothing really came out of it. And that's the sort of disappointment that you face when you are sort of doing quantitative analysis of financial data, because any edge which is there, it basically if it is identified, it gets whittled out. That is the truth about quantitative finance. So right now let's just quickly get to it, because I don't want to make it into a very long video. The code, I already have it here. I have annotated it basically. Sorry, I have annotated it basically so that it's easier to follow. I'll be giving out this code along with all of the intermediate data files that came out of it, because some of these codes took quite a bit of long time to run, because I've used the entire data from 2012 to 2022 to get this done, and basically gathering the data and creating the weight matrices for the best weight for the mean variance on a rolling basis. That really takes a long time, basically around 10 minutes of computing time. So let's just start with it. So initially I started with gathering the data. I'll be describing all of the steps in between, and but we won't be running it today because there's no point. It's already done, right? So first I gathered the data. You all remember how I gathered the data names into one vector. After that, I create an empty list into which I'll be putting all of the CSV files. Okay, so this is the code for for putting the CSV files, reading the CSV files, and putting them into that list. Then this is the code for removing out any nulls, like if there are some other extra files which are empty basically lying inside, like because I'm sourcing these from Google Drive, so there are some specific .ini files in those folders, and those also get collated into the list, but they are null files basically. They don't have anything in them, so because of that I have to remove those nulls before I continue with the analysis. So this is for removing those nulls. Okay, so after that I combine all of that into a data frame. So this data.table is the data.table is the package of which I use the rbind list function. Then the problem is that whenever I use this specific package for rbinding the entire list, rbinding means row binding, basically one data frame stacked on top of another data frame. The list is rbinded. Okay, so the problem is that whenever I use this package, it returns a dual data table and data frame class of object. Okay, and that has some peculiarities that I'm still not used to. So because of that, I have to make it into a data frame explicitly by using the function data.frame. Okay, so I've made it into a data frame. After that, because in some of those files, there is one extra empty vector. Okay, so because of that, while R binding, I need to fill them with NA values so that the consistency of number of columns is maintained. Okay, so then I need to just remove off that column to leave me the good data. Okay, so that is what I've done here. I've removed out that extra useless column. Okay, so that is by using the negative n call data. So basically n call data gives you the number of columns of the data frame, and minus n call means that suppose there are 10 columns, so minus 10. Okay, so the ncol data is just being used to call out the number of columns that are there. The minus 10 basically removes the 10th column. Okay, so you remember how the data is how the data frame things within the data frame can be called out. Whatever are on left side of the comma are rows being called out. Whatever is on the right side of the comma are the columns being called out. So I am calling out the 10th column, and by the minus I'm removing it. So I'm ending up with the data without that last column. Okay. After that, I'm just renaming the renaming the columns of the data, and that is by using names data. So whenever you use this function names, it basically calls out the names of the columns of the data frame. Okay, just the names. Okay, and it returns to you in form of a vector. So that vector can be replaced by another vector. So that's what I'm doing. So names data is equal to see this. So these are the names that I'm placing for the columns. Okay. So now I have got a consolidated data frame of all of the index data from 2012 till this 2022, yesterday basically. Okay. After that, I have to clean up the data because this data is horribly messy. Okay, because NSE has kept on changing the name and the format of the indices over time. Okay, in some of the during some time in 2015, they had even changed the format of the date and then again gone back to the older format. Okay, so because of that, there is a block of dates in between which are in a different format. Basically, they replace the hyphen with a slash. And if you do not go through the data, you basically are lost. Like what happened to those in between rows. Okay. So like earlier they used to prefix CNX for Nifty. Now they just use Nifty. Okay. Then at some of the places they used to use S&P Nifty or S&P this. Okay. So that was the earlier format. Now they have converted everything to Nifty. During some time they had used all caps Nifty instead of only the first letter as cap. Okay, then sometimes they use Nifty 50, sometimes they use Nifty. So because of that, I had to change all of this. I had done a long time back, so I've retained the codes and I've used them again. Okay, otherwise it's very painful. That's why I say that it's a horribly messy data. Okay. So after that, eventually I've cleaned it out and I've saved it as an index data.r data file. This I'll be giving it to you. This is from 2000. This is completely clean data of all of the indices from 2012 till yesterday. Okay. So basically all the data that is available on the NSE in a cleaned format. Okay. After this, I'm going to select out the important indices that I want to focus on. The important indices are Nifty, PSE, Nifty, then PSE, then Pharma, then Auto, Bank, FMCG, Commodities, and IT. Okay, so I made a character vector here, which I've called imp. Okay, imp, I use it for important. So imp is a vector which contains the characters of the Nifty indices that I want. Okay, now I have selected out only those rows within data, only those rows which have got specifically these names in their symbol column. Okay, so that can be like when you want to do for a single element of a vector, then you can use the double equal to, like I've shown you before. But when you want to match for multiple, then this is the function that you need to use. Instead of double equal to operator, you need to use percentage in percentage. Okay, so what this is doing is within data, I want to get those values of data dollar index which are in imp. And these are going to be selected out in a row wise format because they are all in the left side of the comma. Okay, so it is selecting out those rows within data whose data dollar index matches any of the vectors, any of the elements of the imp vector. Okay, I hope that is clear. So this is something that is very useful. I've been using it. I found out about this like maybe 2 weeks back, and I've been using it extensively. It's very useful for these sort of operations. Okay. Now this is mainly for cleaning out that change of the date format. Okay. So for that I use if else statement. I have told you about the if else statement yesterday. I'll not be repeating it, but just to demonstrate. So sub str is basically to select out select out single characters or a set of characters from a character string. Okay, based on position. So basically what this is doing is this sub str is for that. So it is within new data $date. It is selecting out from 3 position to 3 position. Okay, so basically I'm trying to pick out the hyphen. Okay, so sub str new data $date 33. If it is equal to a hyphen character, then as character as date new data $date format equal to this. Okay, but if it is not a hyphen, basically if it is a backslash, then it becomes a not for this logical condition. Then you have to, then the format is with a slash. Okay, so with this one statement, I reconciled the entire date column into the date format that R uses. Okay, after that, so I used it as character here. You can see that I first used as date and then I used as character. This is important because sometimes when you are doing these sort of like using if else or any sort of matrix manipulations, then the date gets converted into Unix format. Okay, so that basically looks like a number 15690 or something like that. Okay, so to prevent that, I am preserving it in form of a character within this statement, and later on in the next statement I'm converting it back into date. Okay, so this is how I'm working with it because it's just easier this way. Okay, so remember that date, if it is in the proper R date format, even if it is a character, as soon as you write as dot date, it will be converted into date. Okay, the next thing, I'm ordering the entire data frame by the date. So this also I've used before, so you can look back to the previous lecture. Then I'm saving it as a imp index data.r data. Basically only the important indices that I'm focusing on are being saved in this one. Okay, after that what I need to do is, now they are in a format in which it is each date and each index is a row. Now what I want is, I want all the indices in parallel columns. Okay, like I want one column for Nifty, one column for Nifty PSE, one column for Nifty Auto, and so on. Okay, right now it is in, like, the index is Nifty PSE, Nifty Auto, with all of its things in the subsequent row. Okay, I want everything, only the close values as a single column, and I want all of them to be parallel to each other. Okay, so this is what I'm doing in this one, in this loop. So my data is equal to list null. I have MV data is equal to list null. I'm making an empty list object called MV data. Okay, so for I in 1:1 length imp. So basically I'm calling out this one. So it will loop over each iteration of the character inside imp. Okay, so MV data I'm just fitting something into the empty MV data list. That will be new data $close, basically the close values within new data, in which the new data $index is equal to imp I. So imp I is this one. Okay, so for the first iteration of the loop, imp I is this one. For the second iteration of the loop, imp I is this one, and so on and so forth. So it will be calling out the close values of that imp. Okay. After that, so this is basically that loop. It's just a 2-line loop. Okay, this will all collate all the columns into the MV data. After that, I am using a specific do.call function of base R to combine all of them, C-bind, basically column bind all of them into a matrix. Okay. Now earlier it was in form of a list. Now I'm combining them into a matrix. Okay. So the thing is that I think I told this to you in the beginning, in the first lecture, that you don't need to use the data.table rbind list. You can easily use do.call rbind here. Okay, that will do the same thing. Okay, only that data.table function is much more efficient. So because of that, I tend to use that for large data frames. However, this would also do the trick in a similar way. Okay. After that, I'm combining them all into, so right now this will output a matrix. Okay, what I want is a data frame, because data frames are a little easier to use, user friendly compared to matrices in R. However, for efficient manipulation, matrices are the best. Okay, so you can say that data frames are matrices with some additional attributes. So MV data is data.frame, MV data. So I'm converting the matrix into a data frame, and I'm naming them as imp. So the names of MV data are imp. Basically, each column has its own name based on this one. Okay. After that, I need to make, so now I have got the data ready. Okay, the entire data is ready. Now I need to run the mean variance function on this. Okay. So what I'm doing is, first, I'm making a separate vector for the dates. Okay. After that, I'm making a separate object, a list object called weights. Okay. Then I'm sourcing the mean variance function like I showed yesterday. I'm specifying the look back period as 20. Okay. Then I'm running a loop over the rows of MV data. Okay, so what I'm doing, it will basically run, just see the statement. I'm starting it as I in n is to n row. Earlier you would have seen I started at 1. I don't want to start it at 1 now. I want to start it at n. That is the nth row. Okay, n is basically the look back period. So I'm starting from the look back period row and doing the analysis on the previous number of rows. Okay, so if I'm starting on the 20th row, I'm doing analysis on 20 plus 19 rows previously. Okay, in the next iteration of the loop, it will go to 21 and 20 to 2. Okay, that data will be used. Then 22, then 21 to 2, 3. Whatever will be used. So like that, it will keep on using, going one row by one row, and using the previous 20 rows for the mean variance calculation, the weights calculation. Okay, so this is basically to specify which rows I want from MV data to be used for the calculation. I'm putting them into X. Then I'm passing the function into passing the X into the mean var function at low precision, and I'm calling out the best underscore weight part of it. So the best weights I want. Okay, and those I am shoving into the weights list. Okay, and after that, this is just to just for my benefit, that I'm seeing that okay, this are being done, and flush console. Okay, so with this takes a long time to run. Okay, so basically it will go from 20 to 2170 something. So that is the number of rows that I'm dealing with. It takes quite a bit of time, like at least 10 to 15 minutes it will take. Okay, after that I am r-binding the weight data. So basically the so basically I'm r-binding the weights. This was the list that I had dumped everything into. I am r-binding it to create the weight data. Then I've saved the weight data also. This also I'll be giving to you along with the rest of the files. Okay, so this basically contains the weight data across all of the entire data series, and it will be with a 20-day look back period. Okay. If you see the diagram that I have in my mean variance page, the live mean variance weights page, in that one there will be a black and white diagram in which there will be some squiggly lines of each of the indices that has been created from this specific type of data. Okay. Okay, after this I need to, so now I have got first matrix that I created was the price matrix. Next matrix that I've created is the weight matrix. Now I'm going to create a separate matrix called return matrix. Okay, so in the return matrix, I'm using the retfunc function that I showed yesterday. Okay, which basically gives me the return for whichever day I want, returns for close on a close to close basis for whatever future period I want. Okay, so here I'm using the using it for 20 days. So 20 days forward, since the rebalance period is 20 days into the forward, so 20 days future returns I require now. Okay, so that is how I'm working it. Okay, so I'm creating a 20-day return profile for each of the rows of the MV data. Okay, the basically the price data, the close data. Okay, so this loop will do that. Okay, it will dump everything into a list object called rect data, that is return data. After that, I am C binding the return data of all of the specific columns, that is Nifty, Nifty PAC, Nifty Auto, and so on and so forth. The return data of all of them will be collated into one matrix. Then I'm converting it into a data frame. After that, I'm naming them with the names of MV data, but I'm specifying a separate suffix to it, that is underscore R20, that is return 20. So that way I'll be knowing that 20 days later return I'm getting. Okay, then I have saved that also as index rect data 20D. Okay. After that, this is just for combining everything into one data frame so that it is saved permanently. But apart from that, this has no bearing on our calculations. Now we can come to the main backtest. Okay, so here I had to use a little bit of brains. Okay, so now I have got one more thing. The return data that I calculated is in percentage terms. It's not in point terms. Okay, so now I have got a price matrix. I have got a weight matrix. Okay, from the mean variance weights, and I have got a return matrix. Okay, so now since the return matrix has been pulled forward 20 days in advance. Okay, so this day's 20-day return is here. They are in the same row. Okay, so if I invest on this today, I will be able to see the return here itself. Okay, now the only thing that is left is to invest based on the weights in the weight matrix. Okay, that was the important thing. So the rules that I made up was that we'll be using 1 lakh per portfolio. Basically, like today, if I start today, whatever I get, like suppose I get 100% in weight for Nifty Auto, I'll be buying with 1 lakh, I'll be buying Nifty Auto. If it was 60-40 with of two separate indices, then I would have bought 60,000 one, 40,000 other. Okay. Now it seems a little complicated to do. Like I also got confused for quite some time. I thought for some 15-20 minutes and then I realized that it is not that difficult. Okay. All I need to do is multiply the entire weight matrix by 1 lakh. Ashte. That's all. Okay. So I multiplied the entire weight matrix by 1 lakh. Okay. I got how much would be going into each, what you say, into each index, okay, on each day. Okay, that much I'll get. And that multiplied by the percentage returns that I've gotten after 20 days, if I multiply those two, I'm getting the return for that row. Okay, so I'm doing a matrix multiplication of 1 lakh into the weight matrix into the 20-day return matrix because it's in percentage terms. Okay, so when I do all of that, I'm basically getting for each day 20-day forward returns based on those weights, how much it will be. Okay, I don't know whether you will get this with one statement or not, but I have to believe that you are getting it because otherwise it's extremely difficult to explain it to you without showing exactly how the matrices look, and that's very cumbersome. You try it out by yourself and then you'll come to know. Okay, so I have annotated it properly here itself. So first in the weight data, I'm removing those 3 columns, which are the return, risk and sharp column. Those I'm removing by minus C, 9, 10, 11. After that, I'm specifying how much I want to invest. That is 1 lakh. Okay. Then I'm creating the investment matrix, which is basically weight data divided. So since it was in percentage terms, so basically 100% weightage was written as 100. So I'm dividing it by 100 and multiplying it by invest. Okay, so basically that much amount it will be going into each of those. Okay. After that, I'm creating the out matrix. Out matrix is output matrix in which I'm multiplying, doing a matrix multiplication of as matrix return data multiplied by as matrix invest mat. That is the investment. Okay. After that is the clever thing, the next clever thing that I did. Now, once I've gotten all of those returns, now the thing is that I'm only investing once every 20 days, right? I'm buying once every 20 days and I'm selling it in the next columns, the return columns, okay, which are pulled forward 20 days forward. Okay. So, but I need to have some semblance of, okay, I'm buying at these dates. Now, since I've already invested 1 lakh, I cannot invest for the next 20 days because it's already invested. Okay. So for the next 20 days, I can't do anything. Then I'll be able to buy again. Okay. So then what I did was I created a separate number vector, a day index, you can say. A day's index I created, which is the numbers from 1:20 repeated throughout the data frame as rows. Okay. So basically, rep 1:20, this is rep is for repeat. So repeat 1:20. How many times I want this to be repeated? I basically divided the n row outmat, the number of rows of output matrix, divided it by 20 to get the approximate number of times it will need to be repeated. I rounded it off, and that is the day index. Okay. Then from the day index, I need to match it exactly to the output matrix. So I have to subtract a few rows from below, and how many number of rows is through this one. Okay. So now I've got a vector which is exactly, which has, whose length matches the rows of the output matrix. Okay. Then I will just select out those rows of the output matrix which are, which match a single index day. Okay. Now suppose I select the index day as 1. Okay. Then if I buy at 1, then I'll only be able to buy again at the next one. I'll be only able to buy again at the next one, and so on and so forth. Okay. So I'm selecting out those rows. Now this number 1 has been is arbitrary. I can select out 2. So the next row, then the next 20th row, then the next 20th row will be selected. Okay, so this you can choose any one of them and see whether the return profiles are differing or not. I have not done that. That can be an exercise for you. So I've done it for only 1. Okay, you can choose 2, 3, 4, 5, 6, 7, whichever you want to choose. You'll be selecting out those rows which have got the day index of 5 or 6 or 7, whatever, whichever one, and you'll be selecting those consistently throughout the data frame. Okay, you will see that you'll end up with equal numbers of investments on each of those runs. Okay, only thing is that they'll be separated by 20 days. Okay, so this is the final backtest. Final BT is outmat with day index equal to 1. So it is selecting out the rows which have got the day index of 1. After that, I'm doing the row sums. I'm summing up the rows of the return matrix. Okay, so of the final BT. So those row sums are basically the individual returns for that previous 20-day period based on the investment, which was based on the weight matrix. Okay. And then I did the cumulative returns, cum returns, that is cumulative returns of that return vector. Okay. Now the thing is that this showed me some profits, as you must have seen. Let me just show you how it was. But I'll just show it to you here only. Alpha leaks. Leaks based stuff. Portfolio backtest. Okay, yeah. So this was the returns of the MVO optimized portfolio. So obviously it looks positive, like you'll be happy that it is giving you a positive return. However, the thing is that when you are managing a portfolio, you always have to benchmark it. So you can benchmark it to, the benchmark is basically Nifty. Okay, so I'm benchmarking it to Nifty. However, the thing is that I can't just do a buy and hold Nifty like we usually do. because that won't be a apples to apples comparison. That will be an apples to oranges comparison. To do an apples to apples comparison, I have to put that 1 lakh into Nifty consistently and take the returns of that. Okay, so that's what I did in the next series of code. So in this one, basically I created a Nifty return data in which as matrix return data 1, that is the Nifty column, multiplied by 1 lakh. Okay, I'm putting 100% into Nifty, and after that I'm selecting out the same index day, that is day 1, and I'm accumulating them into to produce cumulative returns. Okay, so after that, when I run the summary function that I showed on the first day, when I run the summary function on it, summary func returns and summary func NF return data, with this I am getting these results that you can see in the post. Okay, so yeah, that is basically what I did. After that, it's basically just graphing out the entire thing. This block of code graphs out the returns. I'm using two specific this packages. One is called ggplot2, which is the tidyverse package for plotting. And another one is grid extra, in which you can match multiple panels and make it into one graph. So in this, I'm using 2 panels. The top panel is the returns, bottom panel is the cumulative returns, and they are made into 2 rows. So that is how it is working. So that function is grid.arrange. I'll talk about how to make plots on some other day, because that will be another lecture in itself. And I'll be linking this syntax as well as the data frames that I created and saved as our data files with the post. And I hope this was useful. I do not know how many people it's reaching, but kudos to you if you are trying it out by yourself. Happy learning.